The Lewisian complex Lewisian gneiss is a suite of Precambrian metamorphic rocks that outcrop in the northwestern part of Scotland, forming part of the Hebridean Terrane. These rocks are of Archaean and Paleoproterozoic age, ranging from 3.0 to 1.7 Ga. They form the basement on which the Torridonian and Moine Supergroup sediments were deposited. The Lewisian consists mainly of granitic gneisses with a minor amount of supracrustal rocks. Rocks of the Lewisian complex were caught up in the Caledonian orogeny, appearing in the hanging walls of many of the thrust faults formed during the late stages of this tectonic event. Distribution. The main outcrops of the Lewisian complex are on the islands of the Outer Hebrides, including Lewis, from which the complex takes its name. It is also exposed on several islands of the Inner Hebrides, small islands north of the Scottish mainland, and forms a coastal strip on the mainland from near Loch Torridon in the south to Cape Wrath in the north. Its presence at seabed and beneath Paleozoic and Mesozoic sediments west of Shetland and in the Minches and Sea of the Hebrides has been confirmed, for the magnetic field, by shallow boreholes and hydrocarbon exploration wells. Basement rocks of similar type are found at the base of the Moine Supergroup, sometimes with well-preserved unconformable contacts, and these are generally accepted as forming part of the Lewisian, suggesting that the Lewisian complex extends at least as far southeast as the Great Glen Fault. Lewisian-like granitic gneisses of Paleoproterozoic age of the Rins complex are exposed on Islay and Colonsay in the southern part of the Inner Hebrides. Similar rocks also outcrop on Innistrohul off the north coast of Donegal and in Mayo, where they are known as the Anna Gneiss Complex. History of study. The first comprehensive account of the Lewisian complex was published in 1907 as part of the Geological Survey memoir on the structure of the Northwest Highlands. In 1951, John Sutton and Janet Watson built on this work by interpreting the metamorphic and structural development of the Lewisian as a series of discrete orogenic events that could be discerned in the field. They used a swarm of dolerite dikes, known as the scory dikes, as markers to separate the tectonic and metamorphic events into a Scorian event that occurred before the intrusion of the dikes and a later, Laxfordian event that deformed and metamorphosed members of the same dike swarm. Subsequent fieldwork, metamorphic studies and radiometric dating has refined the chronology but supported their original hypothesis. Lewisian of the Scottish mainland. Scory complex. The oldest part of the Lewisian complex is a group of gneisses of Archaean age that formed in the interval 3.0 to 2.7 Ga. These gneisses are found throughout the outcrop of the Lewisian complex in the mainland. The dominant lithology of the Scory complex is banded grey gneisses, typically granodioritic, tonalitic or trondhjomitic in composition. Metasedimentary gneisses are relatively rare. The protolith for the Scorian gneisses are thought to be granitic, with subsidiary mafic and ultramafic plutonic rocks giving an overall bimodal character. Some variation in the age of the protoliths from different parts of the complex and the subsequent tectonic and metamorphic history suggest that there are two or possibly three distinct crustal blocks within the mainland outcrop. The main metamorphic event in the central region was the 2.5 Ga granulite facies Bad Carlian event. The northern region lacks evidence of granulite facies, and in the southern region an earlier 2.73 Ga event is recognized locally. Invariant event. This tectonic and metamorphic event postdates the main granulite facies metamorphic event in the Scorian complex but mostly predates intrusion of the Scory dikes. This event deforms a suite of post-Bad Carlian pegmatites dated at 2.49 to 2.48 Ga and predates most of the Scory dikes, giving a possible age range of approximately 2. 2.48 to 2.42 Ga. The deformation was accompanied by retrograde metamorphism down to amphibolite faces, similar to the later Laxfordian event. Distinguishing between these two events has proved difficult. Major invir and shear zones have been identified in the central and southern regions, including the Canisp shear zone. Scory dikes. This basic dike swarm cuts the banding of the scory complex gneisses and therefore postdates the main igneous, tectonic and metamorphic events that created them. Due to the degree of later metamorphism and deformation in other parts of the mainland outcrop, the only reliable radiometric ages come from the central region, giving an age for the main part of the swarm as about 2.4 Ga. Some dikes, which appear to have been intruded into cooler Scorian crust, give ages of about 2.0 Ga, the same age as undated sills within the Lochmari group. Some of the main dike suites show evidence of intrusion into hock country rock. Most of the dikes are quartz dolerites in terms of chemistry, with less common olivine gabbro, norite and bronzite picrite. The Lochmari group. Supracrustal rocks of the Lochmari group form two large areas of outcrop near Lochmari and Gaelic in the southern region. The group consists of metasediments with intercalated amphibolites, interpreted to be metavolcanics with some basic sills. They were probably deposited at about 2.0 Ga, as they contain detrital zircons that give a mixture of Archaean and Paleoproterozoic ages. Laxfordian events. The Laxfordian was originally recognized from the presence of deformation and metamorphism of the scory dikes. The Laxfordian can be divided into an early event before 1.7 Ga, associated with retrogression of the scory gneisses from granulite to amphibolite facies, and a later event with local further retrogression to gneisses facies, part of which may be Granvillian in age. The early event is particularly associated with shear zones in which the deformed scory dikes form amphibolite sheets within the reworked gneisses. The original mineralogy of the dikes is also changed to an amphibolite facies assemblage, even where they remain undeformed. The early Laxfordian fabrics are cut by a series of granites and pegmatites, particularly in the northern and southern regions, dated at 1.7 Ga. Lewisian of the Outer Hebrides. Much of the Lewisian outcrop of the Outer Hebrides consist of rocks of the scory complex cut by post-Scorian granites. Laxfordian reworking is extensive and very little unmodified Scorian crust has survived. Amphibolite sheets, interpreted to be deformed members of the scory dikes, are much less common than on the mainland. More of the outcrop area consists of supracrustal rocks, about 5% of the total. The relationship between the supracrustal rocks and the Scorian gneisses remains unclear. South Harris Igneous Complex. The South Harris Igneous Complex consists mainly of anorthosite and metagabbro, with lesser amounts of tonalitic and pyroxene granulite gneisses. These igneous rocks are intruded into the Leverbrugh and Langevat supracrustals. Radiometric dating suggests that the complex was intruded over a period from about 2.2 to 1.9 Ga, comparable to the age of the Lochmari group. The gneiss anorthosite, exposed on the northeastern tip of Lewis, is also found associated with metasediments and yields a similar ADM&D model age of about 2.2 Ga. It is considered possible that the South Harrison gneiss bodies once formed part of a continuous body, disrupted by Laxfordian deformation. Langevat and Leverbrugh metasediments. These two belts of metasediments flank the South Harris Igneous Complex, and formed the largest outcrop of such rocks in the Outer Hebrides. Radiometric dating has shown these metasediments to be of Paleoproterozoic age, similar to the rocks of the Lochmari group. The relationship between these metasediments and Scorian gneisses remains unclear. Outer Isles Fault Zone. This fault zone stretches the entire length of the Outer Hebrides, a distance of about 200 kilometers, dipping 20 degrees to 30 degrees to the ESE. The fault rock within the fault zone shows a long and complex history of movement, with the development of fault breccia, mylonite and pseudo-tachylite, indicating faulting at a wide range of crustal levels. Lewisian layers within the Moine. Despite the multiple reworking that has affected Lewisian-like gneisses within the Moine, they show evidence of a common history, although with some important differences. The largest, the Ga.They, shows evidence of a clogid facies metamorphism within both of the tectonically juxtaposed units that make up the inlayer, thought to be associated with crustal thickening during a Paleoproterozoic event at about 1.7 Ga and the Greenvillian orogenic event respectively.